So first and foremost, I have to move my office hours from today to Friday. Just I have a conflict, so from 2:30 to 4:30, same place, but it's on Friday this week. I think I'll have to move it one more time in a couple weeks, but I'll announce it when it happens. Can you all take a moment, if you have a computer with you, to sign up for Piazza if you haven't already? We'll see flurry of typing. That's where the announcements and assignments and all that jazz are, so it's a good thing to be there. Okay. All right, while we're doing that, does anybody have any questions from last time? Okay.
Yeah, I actually did have a question.
Sure.
On the syllabus, you talked about how one of the weeks we're going to focus on open source.
Mm-hmm.
So I'm just wondering what exactly we're going to learn in that.
So the plan for that is to talk about licensing, talk about what open source is, why you care, and some examples probably of various open source projects that might be interesting.
Okay, yeah, so is something we're going to learn actually contributing to?
We may talk about it a little bit, but it's more on the consumption side.
Okay.
You know, and like when you can consume it, and you know, or if you wanted to fork from it, you know, what licenses allow for that and what that means. We originally had it kind of early, like actually I think it was supposed to be this week, but the guy who's going to teach it, my kind of co-professor, is still in India, so he'll be back in a couple of weeks, and we'll do it then.
Okay.
You know, if you have specific things you'd like to hear about,
Yeah.
just let me know, like send me an email or something.
I guess something just if something can be added where we learn how we can contribute to would be interesting.
Okay. Yeah, we should be able to cover it. I mean, it's actually pretty straightforward. We're actually going to kind of talk about it today, except it's the more general case. But it's the same process.
Okay.
So.
Okay. Perfect. Okay.
All right. Any other questions?
Oh.
All right. So let's move on. As you may have heard me say last time, I had like 4 slides left of content that I wanted to get through, so I'm going to do those quickly now. Just by way of background or kind of setup, so these are the kind of topics we're going to cover today, and then we'll cover developer workflow. This is more kind of in the abstract, and then next week we should be doing the kind of mechanics and actually doing it once. So we're going to talk about this stuff here, and basically then we'll have a quiz here about the concepts that we talked about before, as well as a little bit on the roles. I decided to move the activity of like asking you questions about the roles until next week, so you can actually review the questions and answers that people submitted without having to like blindly read them very, very quickly. So I thought that would be fair. All right, so moving right on. Let's talk about virtualization. Okay, so traditionally, when you talk about computers, right, you would have a piece of hardware like this laptop, and I would install an operating system on it, and then I would run, you know, whatever my software is on it. When you're in a data center, okay, that's a little more complicated, right? Because if you have a physical hardware, then when, let's say if you're into it and you make TurboTax, when tax season comes, you have to have enough hardware to run the worst case scenario, right? That's very, very expensive when you have a spike like TurboTax might, or like Amazon does at like Christmas time. That means you need 100 machines at, you know, I'm making up numbers here, but 100 machines at those periods of time, and 5 the rest of the time. Nobody likes that. That's very, very expensive, not very good use of resources. So one of the things that came along to kind of replace, or to try to solve for that problem, basically we refer to this as like increasing the density in the compute world. And so what we did, so that one of the very first things was to try to separate the different applications that were running in different environments, and we used a technique on Linux called chroot, which is change root, but it's Linux, so everything has to be like crushed down into the smallest number of letters you can get it. And it's pretty straightforward. It just says, it's literally saying there's an operating system here and there's an operating system here, and when I chroot across, I get a different set of libraries or whatever that I might need for an application. So not very sophisticated virtualization, very useful for certain kinds of scenarios. This is super flaky today. So let's see if I can make this a little bigger for me, so at least I can see what I'm talking about. Then next came along virtual machines, okay? And so what this is let's run it as if I'm running on physical hardware, but I'm gonna manufacture like all the drivers and all that stuff so that the operating system thinks it's running on hardware, but it's not actually, okay? So that we call that a virtual machine. Hugely popular in this space is a company called VMware. You may have tried, they make a desktop client so that you can run virtualization locally. Another one is, it's also hugely popular, is VirtualBox, made by Oracle currently. Like they acquired it. Both of those solutions let you run your own virtual machines, like on your laptop, but they also, well, not VirtualBox, but VMware also lets you do it in a data center. VirtualBox is really just for consumers. Why would this be useful as a developer? Well, let's say you have two different clients, one that is running a .NET application on Windows, and one that's running a Ruby application on Linux, and you're running a Mac, right? So virtualize those operating systems, and then you can run both. So that's what's useful for it as a developer or as a software engineer. In a data center, it's super nice because you can say, I'm gonna run a web server and I'm gonna run a database server on the same physical hardware, but I wanna increase the density, right? So when it's slow, maybe I run one each, right? But then when I wanna have a whole bunch more web servers because it's tax season, I can spin up a whole bunch of virtual machines running just web servers. But it's all on the same physical hardware. So the other one I want to mention here is KVM. So on Linux, oh sorry, I didn't mention VMware and VirtualBox are both proprietary, speaking of the open source question earlier, so you have to pay for them. VirtualBox I think is given away for free, but there's like upsell. VMware is, I think, always costs money, but KVM is a virtualization solution that's open source and free, therefore, but it only runs on Linux, and it's brilliantly named Kernel Virtual Machine. That's what KVM stands for. This is super fleeky today. Okay, so I run my virtual machines on Linux using KVM because I'm used to it, and it's free and it's open source. All right, so however, right, so if you have virtual machines, they're great, okay, you can increase some density because you can say, okay, I have this whole operating system, etc., on one machine. The problem is I have to carry the whole operating system, right? When that's not really what I need. So in the case where I was giving the example of Mac running a Windows machine and a Linux machine, you do need the full operating system. But what if you're just running 67 different web servers that are all based on the same operating system? Okay, so that means you have to spin up 67 different virtual machines with their own drivers, with their own RAM allocation, with their own disk allocation, et cetera, et cetera, et cetera. And while the technology has actually gotten very sophisticated about this, increasing the density a lot, you still have that overhead. So technically speaking, there's a technique called containerization that's been around for like 20 years, but it was incredibly hard to use up until 5 or 6 years ago. So there was a company called, I'm blanking on the name of it now, but they changed their name to Docker, which was their major product, but they were basically a cloud provider, and what they did was they figured out a way to make containers much simpler. And what's a container? Well, a container is like you're in your own operating system, except without the overhead of allocating specific RAM and that kind of stuff. So when we talk about it from a Linux perspective, we have two different two different kinds of code. We have what's called kernel space and what's called user space. Kernel space is, intuitively enough, all the stuff that runs in the kernel. A kernel is what activates all your hardware, it boots the system, all those kinds of things. Those are all in kernel space. They have infinite privilege over the machine, and when you run a virtual machine, you have a kernel per virtual machine. When you do a container, you actually just get user space. And what's user space? User space is where your web server runs, or your Firefox browser runs, okay? Those are all the things that don't have infinite privilege on the hardware, but they are all the things you actually use, right? So when you containerize something, it means I'm gonna stick my web server in a container in just this user space. So that's advantageous because you may have maybe slightly different versions of Ruby, for example, running various applications on the same hardware. So you want the separation as if it was separate hardware, but you don't want the overhead of the operating system for every single instance of the web server, right? So you separate the user spaces into containers. And this company, Docker, made it hugely popular, like I said, 5, 6 something years ago, by basically making it so you could write a text file and build a container. And it was just like normal commands that you might run to set that up normally, but you could kind of operationalize it, and it's super easy. There's a whole mess of add-ons to that, which we're not really going to talk about too much. But things that allow for, if you remember from last week, orchestration, because once you have a database and a web server in 2 different containers, well, now you need to make sure they can talk to each other. So you use orchestration techniques for that. At the kind of desktop level, you know, you would use something like what's called, I just blanked on it, Docker, not Swarm, but the other one. But at the kind of in the production environment, the really popular one right now, which is open source, was actually originally generated by Google, called Kubernetes. And it's fairly complex to use. We actually make a product on top of that called OpenShift that makes it a little bit simpler to use, but it's intended for data centers. They're pushing hard both the kind of the community around Kubernetes, but the community around OpenShift, at making it so that it's much more consumable at a desktop level, so that a regular developer can use it easily. But it's a lot more complex, right? Because now you're dealing with lots of different services that got to talk to each other. So popular ones for this are Docker is the company. Then they did something else to make it more confusing, is that if you want to download and run it now, the product is actually called Moby. I don't know where they came up with Moby, but so if you see Docker or Moby, they're basically the same thing. And if you Google search for how to use it, look for Docker, not Moby, even though that's technically the name now. We make a competitor, in a sense, to Docker called Podman, which has some kind of key differences about how it runs. Basically, it doesn't have a runtime in the background, but it is almost kind of command line parallel. But it's using the same kind of technology. It's just a different wrapper around it. There's another one that's not commonly used. Yeah, go ahead.
I posted the lecture slides on Piazza if you guys want to follow along, because that's being.
Oh yeah, that's a good idea.
Yeah.
So there are on Piazza, and sorry, it's flickering in and out. It might even be worth turning it off. So
It was happening yesterday too. I was in this class.
Oh, okay.
Yeah.
So LXC, which is also brilliantly named Linux Containers, but shortened, is another mechanism for developing containers using slightly different techniques, but at the end of the day, the technology is roughly the same. Same with systemd spawn, it's just another one. There's probably another 10-ish that I didn't bother to mention because they're they're just not very popular, so you're not going to come across, or you're not likely to come across them. All right, any questions? All right, so I just wanted to kind of give you a brief overview. Containers obviously let you massively increase the density, right? Because you don't have the overhead of the operating system itself, you just have user space. And so you can get lots and lots of different kind of virtual applications, right, into one same physical hardware. So if you go to like Amazon Cloud, for example, when you go buy an instance, you're actually getting a virtual machine normally, but you can also now go buy containers from them as well. And serverless, if you've ever seen that, is kind of like also running in a container, but it's even more transparent of what you're doing, but that's a container as well, usually. All right, moving on, completely different thing. I want to talk about a little bit about project management. So project management, this is how do I get from idea to like out the door, right? And there's lots of different mechanisms for this. Traditionally, we followed a mechanism called waterfall, and probably the gold standard of it was called the Rational Unified Process, or RUP, which was great, except that it's a waterfall. So what you would do, when you were doing development 20 years ago, it was very expensive to build an application, as in time as well as people. So you would go and get perfect requirements up front, then you would develop the code for it, you develop the architecture, then you develop the actual code, then you would ship it. Problem with that is that between point A, when you went and talked to them about the requirements, and point B, when you actually ship the application, lots of those requirements tend to change. Or, because humans are very bad at speaking, the requirements as articulated did not actually reflect what the users needed. So what you started to see was some alternate solutions called, that kind of loosely get grouped under Agile techniques. And there's an Agile manifesto, which if I remember, I'll go back and update the slides and put the link in, which kind of develops the characteristics of an Agile method. And basically, the short version is release early and often, okay, so that your consumers can see what you're doing as quickly as possible so that you can rewrite. What has made this possible, okay, which I think is a lot of people gloss over, it's like, why didn't we just do this from the get-go, right? It seems like an obvious way to do it. Well, if you were doing an application in C or C++, and even if it was a web application, that's a lot of like, you know, what you refer to as like big iron, right? There's a lot of code that has to go in there before you even get something you can see. But if you take a language like Ruby or Python or whatever, you can get to an application that you can present to users very quickly. And as well as the fact that you can gut the entire application and rewrite it also very quickly. So Agile processes started to be possible, okay? And so there's three big ones, okay? Although, and I wanted to try to find the slide, but I couldn't find it. A friend of mine, somebody who teaches Agile practices inside Red Hat, has a slide with like 100 different Agile methods, okay? But there's three you typically encounter. One's called Scrum, one's called Kanban, and one's called cyclic waterfall. So Scrum, the idea with Scrum is that you take these things called sprints, okay? You, at the beginning of the sprint, you say, okay, these are the features we're gonna develop, okay? And then you break it down into small enough pieces that each person can work on it. Then you take your team of 6 or 8. Amazon actually refers to it as the 2 pizza rule, so your team should be no bigger than you can feed with 2 pizzas. So then you kind of say, okay, we have a sprint. A sprint is typically 2 weeks long, okay? They can be as small as a week, they can be as long as 4. I have almost never encountered them, actually it's rare I've even encountered 4, but never longer. Okay? The idea is you do something short and fast, but the key is that every 2 weeks, let's say in that sprint, you release something. Okay? You actually make something production ready. It goes out to the public. Excuse me, public may be just your stakeholders, okay, not actually public, but the idea is that you have built something that other people can see that are not on your team. Okay? As well as every individual member of the team will do a demo of what they worked on for the past 2 weeks. And that demo might be, well, I tried this thing, it went terribly, and so here's my massive failure, and here's the details about how I failed, okay? So it's very important to have this demo and have a releasable thing every sprint. So typically Scrum is more suited to like new applications-ish, okay? So where you have a good idea of the features you want to develop, you want to kind of be cyclic about how you do that feature development and roll stuff out. There's an alternate model that works better on an application that already exists and is in maintenance or small feature mode, which is called Kanban. So it's got a very similar model in that you have, sorry, I didn't mention this before, but you have this backlog of like issues or features or whatever that is ordered in priority. And for a Kanban style development cycle, you typically have sprints as well, basically just as a bounding box, but you're just taking the next thing off the queue all the time. Okay, so you don't really have that planning meeting. You just kind of say, you know, I'm developer, I finished the last thing I was working on, I go back to the Kanban board, I pick the next one up, okay? There's a little bit of latitude in that, like say, you know, if I'm a developer who's a UX developer, maybe I'll only pick up features that have front-end development, and a back-end developer might pick up features that are back-end development or bugs or whatever. But for the most part, all team members are usually similar, and anybody can pick up the next thing. And you basically pick it up by assigning it to yourself and carry on your merry way. So you might, as a human, right, I might fix or solve 6 of the tickets that are in the Kanban board one sprint, or I might solve 20, right? You generally try to size them roughly the same. So if I do 20, you should also be doing 20-ish. So otherwise our sizing of our individual features are probably not correct, right? And they should be broken down more or whatever so that they're roughly equal in size. So there's a lot more to both of these things. Obviously I'm just kind of giving you a brief overview, but basically that obviously may sound like it's tricky to get a handle of when things are going to release if you do this stuff. So there's various project management techniques called like burn down charts and things like that, which and velocity, which try to calculate how long it'll take till you actually get feature A released, right? All right, does that make sense so far? Okay, so cyclic waterfall is one of the earliest agile methods, which is basically you take the waterfall method, which is like requirements gathering, architecture, coding, QA, release, and you make it cycles that are much shorter. So your waterfall might be 1 to 2 months, right? Where you do all those stages, but the reason you call it cyclic is because you do another waterfall right afterwards. You keep going, right? So it's a cycle. So obviously, it's very easy to understand cyclic waterfall if you know waterfall. That's why it was one of the early ones that got adopted. I was in a consulting company for a long time, and that was what we transitioned to from our traditional waterfall method, because we didn't like anything that took a year. Like if we were doing a project for longer than 3 months, we all got bored and left. So we would do cyclic waterfall before some of these other agile practices really took off. One other term that's kind of related to project management, but is also very popular, is DevOps. You've probably seen this elsewhere. So the idea here is that one of the problems with waterfall and traditional development mechanisms is that you have all this striation in role types. So going back to our last class, right, we labeled all these role types. So if you have different humans in each of those role types, the problem is that they don't have any experience with what the other roles do, okay? So as a result, if I'm a coder and I don't do any operations, I don't know the kinds of problems that an operator runs into. I'm gonna turn this thing off, it's driving me crazy. So what you might do, so one way that they try to solve this traditionally is that I, as a software developer, might do rotations through support or through operations, just so I can kind of see what that experience is like. Because I'll write different code if I know how it's going to go in production. What DevOps says is, and it's basically a mashup of developer and operations, it says that all developers should also operate the applications that they deliver. Okay, so this is interesting because traditionally you hand it off to a set of sysadmins, but you're still, as a developer, on what we would call, so there's level 1 support, which is you pick up the phone and call somebody and they basically tell you to turn off your computer and turn it back on again, and that's the extent of their contribution to your problem. But then there's level 2 support where they start being able to talk to you like as if they actually understand the application, and then level 3 support is normally basically where they pull in the developers themselves into a problem space. Well, if you think about it, why do they do that? Well, it's because the operators don't actually know the code very well, right? And vice versa, the developers don't have any experience with making sure it's operational. So what DevOps is it was based, I think they coined the term, but there's a book that I do have a link to in here called The Phoenix Project, which is a novel actually, it's kind of fun to read, I highly recommend it, about what happens when you don't do this DevOps-y thing. And so it says, like, let's make the developers actually operationalize and be responsible for it, because the best way to get bugs fixed regularly is if I'm on pager, and so at 2 in the morning when somebody runs into this bug, I get paged. I promise you, I will fix that bug a lot faster than if you get paged, right? Does that make sense? So that's the idea behind DevOps. I would say, is where the vast majority of development shops are going. The problem is, many organizations say, ooh, cool buzzword, I'm gonna label my operations group DevOps, because it sounds cool. Not because they actually do DevOps. They're still operators, they're just like they were before. They might be crossing into what we talked about before, site reliability engineering, but they're really just operators. So, be cautious when you see, like a job ad or something like that that says, come join our DevOps team. And make sure that what they're doing is actually DevOps, or that you're actually going to be an operator. Neither one is necessarily bad, but don't take it at face value, because it's a very buzzwordy term. Oh my god, I gotta go faster. All right, security terminology. So Oh, this is tough without the slide. Oh, but you guys have them, hopefully. Okay, so security. This is actually in that book, the Phoenix Project. One of the major characters is the person who's responsible for security, and it's really interesting because they're over here off to the side with no actual control over the development or operations, okay? Which is, I would say, largely typical. What's the problem with that? Well, again, if developers don't understand what they're trying to deliver and how and things like security vulnerabilities, then they won't code it well, okay? So what I mostly wanted to cover here was just kind of terminology, which is the most common one is CVE, okay, which is common vulnerabilities and exposure, or common vulnerability and exposure. This is, there's an organization, which I can't think of the name of, that actually labels them all. Okay, so every time there's a bug found, you know, that has some sort of security implication that's in the wild, particularly like in open source, there's an organization that says, okay, this is number 2, and then this is number 3, number 4, number 5. So you'll see CVE and then some long string of numbers because unfortunately it's well over 10, right? So it's in the hundreds of thousands. And so if you'll basically get notified on a machine, you'll say, oh, you are potentially at risk for these 6 CVEs. There's patches out for them. They apply patches. Usually they kind of go hand in hand. Sometimes a CVE will be what's called embargoed, so they won't release the fact that there's a known vulnerability until they have a patch. If it's considered sufficiently secure, there's lots of debate on whether that's a good idea or not. So a couple of other terms here, malware. Are y'all familiar with malware? It's just bad software, right? Software that is actively trying to do something malicious, hence mal, to your computer. There's ransomware is getting very common lately, which is basically a piece of malware that actually encrypts part of your data, and then you have to pay them money to get the decryption key. So it's a lot of fun. It's hit some big orgs pretty badly. And then viruses. So the difference between malware and viruses is a little subtle. Malware is normally software that you install that has like a bad thing embedded in it. So you see this all the time in like phone apps, okay? So arguably Angry Birds, first version, used to strip all your contacts and upload them to Angry Birds' servers. Arguably if that's strictly malware, but you get the idea. I installed Angry Birds, I took the initiative, and then they stripped all my contacts, okay? Whereas a virus usually exploits some like CVE or something else to break into your machine, okay? And like I said, so the difference is kind of subtle, and they'll often be labeled both ways. The only other thing I wanted to kind of mention is with CVE, sometimes they're like cool enough or bad enough that they get their own names. So a few years ago, there were 2 of them called Spectre and Meltdown. If you don't know what those are, you should go look them up. They're pretty crazy. I actually just saw a demo at a conference I was at 2 weeks ago of a guy who was able to take one virtual machine in Amazon and another virtual machine in Amazon that shouldn't be able to talk to each other and actually transfer a video across by basically using speculation on memory cache misses. So those, and that's related to the Spectre and Meltdown problems. So that's kind of Spectre and Meltdown. Go look them up on your own time if you want to. There's lots of these all the time. You'll see them make the news. There was one called Ghost something or another that was pretty recent too. But what I wanted to talk about there a little bit is that there's a lot of research going on right now into, there's a horrible term, timing channels or kind of speculative processing and that kind of stuff, and taking advantage of that to hack machines. A very interesting subject, not for this course, but definitely look it up if you're interested in that sort of things. Rowhammer is another good example of one of these techniques. Very cool stuff. All right, this is pretty quick and dirty. Other terminology. So you normally pronounce all of these, which is kind of weird. So we have IaaS, which is infrastructure as a service. We have PaaS, which is platform as a service. Infrastructure as a service is what Amazon gives you, so it gives you a new virtual machine. PaaS is what like OpenShift or Heroku give you, which is giving you a platform. This term is actually getting unpopular, like as in people don't want to be associated with PaaS anymore. I'm not 100% sure why, but it is falling off. But the idea being that instead of just a bare machine, I will get a web server with Ruby installed already. Okay, and that's what makes it a platform versus just infrastructure. Then SaaS, which is software as a service. So if you've ever used like Salesforce, or I'm trying to think of some other good examples. I mean, arguably something like LinkedIn is technically SaaS, right? It's giving you a service. You don't ever actually install the software, right? You're just using it kind of on the internet. Mint, you guys might be familiar with Mint. That's a good one for kind of financial services stuff. A couple of the terms, net neutrality. This is the idea that, so one of the problems with, like, let's say Netflix, okay, is that Netflix can lock up the market for any competitors to Netflix, okay? How can they do that? They can actually pay money to the ISPs for their, like, video streaming. So in other words, they can say, we'll pay you an extra $10 a month to prioritize our data over everybody else. Okay, why is that bad? Well, because if I do a startup of video streaming, I am not going to get prioritized unless I pay the $10 a month, which as a startup, I can't, okay? So net neutrality is this idea that you can't pay to play, right? You can't pay to have a better version of something. And so this has been a lot in the news because it was actually passed for a while, and then it got pulled back. So if you are a T-Mobile subscriber, for example, you now get Netflix for free. Okay, that is actually anti-net neutrality, right? If you get Verizon, you get something similar. Disney Plus, yeah. So again, anti-net neutrality. It's great for me as a consumer until the next big thing that wants to come along can't, right? So this is what's the problem with this thing, is that it seems good when you're just consuming it until you think about the ramifications and implications of it. All right, so that's net neutrality. Definitely read up on that. It is, if you are in any sort of computer science or computer software or whatever, this is something that will matter to you for the next 20 years, so pay attention. Do you have a question? Sorry.
Yeah, so for IaaS, PaaS, and SaaS, like what does as a service mean?
Okay, so as a service means like, I am just gonna buy it by the hour, right? Instead of installing it and running it myself. So there are a whole bunch of other letters that you can put in front of as. And there's all kinds of bad and dirty jokes around it as well. But the point is that I'm paying for something by the hour rather than installing it, and rather than having like a perpetual license. Okay? So, and paying for it can be a little unclear, right? Maybe like Mint, for example, appears to be free, but they're actually selling your data in the back end. That's why they can give it to you for free. So, but Salesforce, for example, costs many companies millions of dollars a year. Okay, but you never actually run Salesforce yourself. So, infrastructure as a service, I go buy a VM for an hour. I pay $1, I pay $50, whatever it is. That's what makes it an as, right? The terms also tend to come and go a little bit, except for the ones I brought up. All right. I'm actually going to skip this slide, but basically I was going to defer the interview question stuff until next week. So make sure we'll distribute everybody's questions and answers. Make sure you read up on those, and then we'll ask questions next week. What time is the class over?
2:15.
Yeah, okay. All right. So this is just some of the stuff I mentioned. There's a book called Site Reliability Engineering that was written by Google, or some people at Google, about what they do. It's a very good introduction to that concept. Like I said, the Phoenix project talks about DevOps. There's actually a new one either out or coming out that's like a sequel, but I haven't read it. And then, I thought I put another one here too, but yeah, so just kind of some random things that might be useful to read. All right, so now getting on to the topic of this class, which is, let's start off with version control. So how many of you know what version control is? Raise your hand. Okay, so unlike the rest of the world, which I really don't understand, in software, we always do things with versioning. Okay, so you've all used Google Docs? Have you all found in like the doc, where you can actually go back and see prior revisions? Okay, that's super handy, right? When you accidentally delete a big paragraph and you're like, oh boy, what did I do? Or somebody else comes and takes a look at it and says, oh, well, you should strike this, this, and this, or whatever, and then you're like, oh, they're an idiot, and you want to go back. So that's revisions. That is version control for the masses, okay? When we do it in software, we use various tools that actually track every time we make a change. So the terminology is, generally speaking, you make a change and then you do what's called a commit to say, okay, I'm ready, I'm satisfied with this change. I want to move it into the log so that I can roll back to it if I want to, but it's in the log now and it's official. Big thing you can do is that you can take any point in the log and do a difference between what you have now and what you had 6 weeks ago, right? It is not uncommon practice to write a bunch of code and then realize that the way you had it before might have actually been better, or that you want to bring back a piece of it or something like that. So that's why you might use and I'll say diff most of the time for differences, because that's the name of the command line tool in Linux, and that's where it comes from. So that's basically the idea. With version control, you just kind of say, every time you're satisfied with a change, you do a commit. Usually, you do what's called a commit message, and you explain what you were doing. So, for example, going back to the CVE reference, you might explain that you're fixing that security vulnerability, or you might be fixing this bug, or you might be implementing this feature. So generally speaking, it's a good idea to have intelligent commit messages indicating what you did and why, so that 6 weeks from now, you have some recollection, right? Or, perhaps even more importantly, so the next person who's looking at the piece of code that you worked on knows what you did and why, especially when you do something terrible. I want to mention a few of the products that people typically use. How many of you have heard of Git? Okay, so that is by far and away the most popular one, generated actually by Linus Torvalds, the guy who invented Linux, because like must have been more like 10 years ago now, he was using a product that was closed source, but was free to run the Linux tree in. They went proprietary and started charging money. He said, and took like 2 months off and wrote Git. So yeah, it's kind of ridiculous. So it became super popular, primarily because it learns a lot of stuff from all its predecessors about what is terrible about version control systems and tries to make them better. It is a particular type of version control system, which is called basically a peer-to-peer source control system or version control system, in that you don't have to have a remote server. You can just work on it locally or with just somebody else. And that's a difference between two more that I'm going to mention. One is SVN is the command line normally, which is what you'll see a lot, but it actually is short for subversion, which is actually a replacement and does a lot of things better than CVS, which common version system? I can't remember what the C stands for. But CVS is the granddaddy of them all, and so CVS truly terrible. Then Subversion, quite a bit better. Both of them rely on a remote server to be able to actually share things. Then it also kind of replaced with Git. So Git is the most popular one right now, if you're in kind of the Linux or Mac ecosystem. On Windows, Microsoft makes a product that they used to have that was called Visual Source Safe, but now has been replaced with a much better product called Team Foundation Server, which does a very similar thing. But many, many Microsoft developers actually use Git now as well. And there's first-class support for Git in most of their IDEs and that kind of stuff. But Team Foundation Server, you will come into contact with it. I have never actually used it. I've used SourceSafe, but not Foundation Server. One of the big differences, and I'm going to speak to SourceSafe because I don't know Foundation Server, but one of the big differences between SourceSafe and Git is that two people can't be editing the same file at the same time. Okay? So in Git, you can. So I can make a change and you can make a change, okay, and then we have to figure out how to merge it later. With SourceSafe, they avoid this problem by saying, I check it out, you can't touch it. Okay? So there's trade-offs there. I would say most software engineers feel that the right answer is multi-edit and then merge it later, because it's unlikely that we're going to actually change the same lines. So merging is usually not too big a deal. However, it can be a train wreck. Speaking from experience. One of the big things I want to mention is GitHub. You ever heard of GitHub? Okay. You ever heard of GitLab? Okay. So what is GitHub? Does anybody know? I want an answer. Sort of. Okay, so it is Git as a service, okay, with a bunch of extra features, but is in no way does it actually have a true relationship to Git, okay, in the sense that, yes, they support people using Git, but it is proprietary closed-source software provided by a company that is now owned by Microsoft that provides a great service. I use it all the time, don't get me wrong, but it is not synonymous with Git, okay? GitLab, on the other hand, is a less good service, but still pretty good, that is an open source and free software version of GitHub. Okay, so it's another remote repository store, you know, someplace you can back up all your code to or whatever, and it's called GitLab. There's a GitLab.com, so you can pay them, but they also offer their regular version for free, and all of their software, at least most of their software, is open source. So therefore, you can just download it and run it yourself if you want to. Okay? But the big thing I wanted to make sure is clear is Git and GitHub are not the same thing. Okay? Which is a common misconception. Okay. Now, this is actually the hard part. Okay. So, that's great. Okay? But what does that actually kind of mean for how does the developer workflow work? Okay, well, the developer workflow, in the kind of recent-ish era, okay, like 4 or 5 years now probably, is it relies on kind of the concepts behind Git, okay? Not so much the actual command line tool or any of that stuff, but kind of the concept. And the idea is that you're going to take a code base, okay, and you're going to say, actually, so I play this stupid open source video game, and I say to them, hey, I want this new feature. You know, I want the character to avoid plants by default. So I go and I file a ticket, usually referred to, at least in anything in the Red Hat ecosystem, we call it an RFE, which is request for enhancement. Okay? So to kind of distinguish it, it's not a bug, there's nothing wrong with it, it's just this is something I would like. But then the owners of the application come back and say, first they might say, hey, that's a great idea. What about this, what about this, what about this, what about this? And then I answer them, or somebody else answers them, and we go back and forth and, you know, and discuss how this thing will work, okay? Actually, a better example is I made a request on Podman, which is the containerization tool, where I wanted all users, if we pull the same container, I want them all to share it, so I don't have to have multiple copies of it on disk. Okay? So we go back and forth on how that will work. How do we fix the security? How do we make it okay that if I have a copy and you have a copy, we're not bleeding security between the two because I shouldn't be able to see yours or whatever. So we go back and forth in the discussion, and then somebody eventually says, okay, this sounds like a good plan. Here's the write-up or whatever of what we're actually going to do. So that's usually referred to as proposing a change. Okay? These days, that is often done in GitHub. Okay? So you actually go and file an issue in GitHub. It'll have like directions usually about how to do an enhancement or a bug fix, or how to report it with different requests for information and that kind of stuff. And then you'll just see comments and questions or whatever all on that ticket. So it's basically self-documenting, it keeps a log, etc. for that thing. Okay, so that's all done. And unlike my proposal for my stupid video game, the you know, in the Podman scenario, they actually said, hey, this is a good idea. Video game said, that's a stupid idea, we're not doing that. And I was like, fine. So in the container scenario, now someone is going to be assigned that work. It might be the original requester, right? Or it might be somebody on the existing team. But either way, I can actually, as the proposer, now that we've had the discussion about what the change should look like, I can now go write the code, okay? And so what I do is I actually, in GitHub, like the terminology is roughly similar across all the different software, but what I do is I fork their code base, okay? Then I create a branch, okay? Usually labeled with the name of the feature I'm trying to develop. Then I make my changes, okay? And I do various commits or whatever. And then I submit what's called a pull request back to the original project. but it's on its own separate feature branch. It's got its own, usually you squash the commits together so that there's actually only one commit for the feature, even if you used lots of them in between. And basically that pull request comes in to the original authors as kind of an even better request for enhancement, right? Because it's not just the ask, it's the actual code too, right? But, like I said before, don't write the code without getting some approval that this idea is a good one, right? Because you'll get squashed like my stupid video game and they say, no. Yeah?
You're gonna have time for the...
Oh yeah, alright. So, once that pull request comes in, then they basically look at it. You'll go back and forth. 99.9% of the time, it will not be accepted out of hand. You'll have comments. You'll have to make changes. You make those changes, and then you resubmit the pull request. Okay? Eventually, if you're lucky, it gets approved and merged into the code base, and now your new feature is there. And that's about it. You have a lot of responsibilities on the other side of that wall, too, where you have to review those pull requests. And so in our, I think it's the next session, but it might be the one after that, we're going to go through that and get some of that experience and actually see what it's like to do, both a pull request and a review. So this is just kind of giving you an idea of more trying to give you the idea, the concept behind what we're trying to accomplish. And that was